Okay, greetings everybody. This is the third video for Lab 5, Hooke's Law. Now for sheets 3 and 4, we're going to have connect the springs in series. And remember, there's a different formula to calculate the theoretical KEQ. It's for springs in series, the equivalent is equal to K1, K2 divided by K1 plus K2. So now I'm going to leave it all up to all of you. You know, part of the goal of these online labs is learning how to enter these things in Excel on your own. I can't always spoon feed you all the formulas. So you're going to have to figure out how to enter this formula into cell H5. In other words, you want to do E5 times E6 divided by, and be liberal with the parentheses, but you want to do, you know, parentheses E5 times E6, close parentheses, divided by, left parentheses, E5 plus E6, close parentheses, and then maybe have two outermost parentheses. But I'll leave that up to all of you. Remember, you know, you want to use the dollar sign thing because that's Excel language for these. The K values are not leaving those two. Now, for sheet 3, you want to use, again, K values of around 300. You want them, again, both to be the same. Here I've got 300. Let me go ahead and go to the simulation. Now again, first we want to go over here to parallel. And then displacement, equilibrium values, everything should be checked. I'm going to, what I say, 300. So I'm going to go 300 and 300. All right, I've got parallel. Then again, now notice on the simulation, on the spreadsheet, in sheet 3 again, we're going from, the force is going from 0 to 18 newtons in increments of 2. So again, see, for 2 newtons, my x is 0.013 meters. Again, it's not rocket science, it's very straightforward, 0.013. Then go up to 2 for yes, it's very easy to fill out, you know, the rest of this column. Then you all should know by now how to create the graph. Now the thing is, now for sheet 3, you know, you could use the same K's that you used in sheet 1. Notice here I use 290 and 290. Then in sheet 3 I'm using 300. 300. I don't care. Just keep them around 300, but the key is in sheets 1 and 3, the 2K values have to be the same. Now for sheet 4, here's where you want to choose. You want K1 and K2 to be different, and you want them to be, here's where you want the substantially larger values. So I'm going to use a K1 of around 450. And I don't think K2, I think the limit in the simulation, I believe 600 is the limit. So let me see, 450 and 600. Yeah, 600 is the limit for, so I'm going to do 450 and 600. Okay, so, you can use, you can use 350 and 500, but you want to use values of K that are, a little bit larger than in 1 and 2 we did, around 300. You want to do 400 and 550, you can do, however, but basically you want to choose, both values should be well above 300. 450 and 600 probably works. Then remember on sheet 4, now here notice the force is being incremented by 10. Because that gives us more than enough data. We don't want to mouse milk this thing. But just remember, you want to use those force values. So I'm going to go up to 10. And see, x is 0.039. Go ahead, type it in. Then go up to 20, 30. You get the idea. It's not a big deal. Now again, in cell H5, you're going to have to enter the correct Excel formula that will give you the theoretical value of KEQ. K1, K2 divided by K1 plus K2. Again, I'm letting all of you figure that out on your own, but it shouldn't be that difficult. But if you're struggling, let me know. But remember, once you enter the formula, the correct formula into H5 in sheet 3, you can just copy it and then paste it into sheet 4. That's the beauty of Excel. Then again, once you get all your values, create your graph, do exactly what I did in sheet 1. And so you should have 4 sheets that are going to look, they should all look very, very similar. So I think that's it. And again, if you have any questions, please let me know. I'd rather give everybody a day or two extension and have the lab done correctly than get some, shoddy piece of, get a lab that's really shoddy and not up to par. The goal is you want to be comfortable, using the simulations, using Excel. I'd rather you take an extra day or two. Say, Dr. Gomez, I'm really stuck. I need a day or two. And make sure you're really comfortable with getting formulas entered, graphs created, trend line. I mean, I guarantee by the end of the semester, you're all going to be really, really proficient using Excel. So let me go ahead and save this video and get it posted. I mean, really, you're doing the same thing 4 times. The only difference is sheets 1 and 2, the springs are in parallel. 3 and 4, the springs are in series. And remember, for sheet 4, I want you to use relatively larger values of K compared to the first 3 sheets. So there. Let's go ahead and let me save this video and get it posted. Any questions at all? You know where to find me. Just let me know. I'm more than happy to help you. I mean, I really like Excel. I find it fun. It can be a little bit tedious, but it really does produce some really nice graphs.